Alright, well, welcome back. We are talking about writing sequence rules. Don't think this is going to be too terribly long. So just as a reminder, we've got arithmetic sequences and we've got geometric sequences. There's your explicit formula for arithmetic and for geometric. There's your recursive formula where you're always going to give a number for the beginning of the sequence and then the nth term, and then same thing over here. So that's why I've got this n greater than or equal to 2. So, all right. So start looking at some problems here. Here we've got an arithmetic sequence is given 28, 21, 14, 7. They are asking us to write an explicit formula for the nth term. Okay, so we're going to kind of figure out what's going on here. This first term, we'll label that as a sub 1. Looking at what's going on, looks like we're going down 7, down 7, down 7. So definitely have a common difference there of 7. Negative 7 actually. Didn't write it here, but I did write it over here. So here's that formula applied. So the first term, 28, plus d, the common difference, times n minus 1. And we'll just go ahead and simplify this a little bit. So distributing that negative 7, so we have negative 7n, and that negative 7 times the negative 1 becomes a positive 7. And rearranging that, we have negative 7n plus 35, so it's combining that 28 and the 7 there. And that's a good formula. The nth term is equal to negative 7n plus 35. Your homework might let you get away with writing this, but this is a real nice concise answer as well. Alright, so let's talk about a recursive formula for an arithmetic sequence. So here's our first term, negative 28, so that's a sub 1. If we look at what's going on here, so it looks like we are adding 6, adding 6, adding 6, so pretty consistent there. Looks like common difference of 6. So to write the recursive formula, we'll write the first term, a sub 1, is equal to negative 28. And the nth term is equal to the n minus 1 term, so the previous guy, plus 6. And that's valid for all n values greater than or equal to 2. Now you might be able to understand a little bit more why we have that. So for n equals 2, it's this. For n equals 3, it's this. For n equals 4, so on and so forth. The only one that's not defined by this rule is the first term. All right, that's a great answer there. Some of these other questions that we'll be looking at, this is just going to be determined whether it's arithmetic or geometric, so we're pretty much experts at this. So we're noticing common difference of 2 all the way, that's arithmetic. Here we're seeing multiplied by a half, multiplied by half, multiplied by half, that's geometric. In this one, the 4, 2, 1, 2, we can see that from the 4 to the 2, that could either be a minus 2 or it could be times a 1/2. Not really sure which one of those it's going to be, but looking from the 2 to the 1, we're clearly that's going to be a 1/2. But then if we're going from 1 to 2, that's multiplied by a 2. So that's not a consistent pattern here from term to term. That is a neither. Okay, getting close to wrapping things up here. We'll write the recursive formula. So we'll look and see what's going on here. From 8 to 5, that's a minus 3. 5 to 2, that's another minus 3. 2 to negative 1, that's another minus 3. Clearly, this is arithmetic. The first term is equal to 8. And the nth term is the previous guy, so a sub n minus 1 minus 3. That was nice. Over here, looks like this is probably going to be a geometric sequence. So 3 to the 30, that's a times 10. 30 to the 300, that's a times 10. 300 to the 3000 times 10. Clearly, we're multiplying by 10 between terms. First term is 3. The nth term is the previous term times 10. That's it. There we go. That's applying and writing some rules, some function rules for formulas rather, recursively, explicitly. Good luck on doing that on your homework.